So, hello and welcome everyone. I hope you are enjoying this EclipseCon. I'm Marcello Martina and this is my colleague Pierantonio. And today we will talk about how you can protect your intellectual property on your AI models when deploying them on the edge. The AI models that you deploy have very high value since you usually invest a lot of time for building them. So this presentation will be divided into two main sections. Into the first one, we will introduce you what the challenges that you will face when deploying applications on the edge, and and especially why you should do the AI inference directly at the edge device. And then how you can address the main challenges with the Eurotech software stack that we built purposely for this type of problems. And then we will see also some successful applications that we have currently running. Then in the second part, my colleague Pierantonio will talk more specifically about the security. And he will explain what are the main security concerns that come with deploying applications on the edge, and then how, with our framework, which is called ESF, you can protect yourselves from external threats. And then we will see also an example application. So first and foremost, why do you want to deploy an AI model directly at the edge? So the first maybe thought is that you have directly access to the resources that you're interested in directly onto the device. So you will benefit of especially low latency when processing the data that you require. And because of that, you could perform real-time analytics because you are close to where the data is produced and you are on the device itself. And then you may want to send just the meaningful data to an external cloud service for further processing, for example. So by doing that, you will reduce data consumption, the internet bandwidth, and you will also save some cost on the cloud storage, especially. By sending less sensitive data over a channel that you do not have control over, like internet, you will benefit also of an improved security because you don't expose sensitive information outside of the device. And last but not least, you will benefit also on some more scalability. If you have multiple video sources, for example, you don't need to send each channel directly on the cloud. You can process it first on the edge device so that you can send just one maybe common stream up on the cloud. So,
can I have a question?
Yes.
If you look at point number 1 and 2, it's more or less related. For example, to address real-time analytics, you need low latency.
Yeah, these are closely related.
What is missing here could be the cost of data archiving at edge, at cloud.
Yeah, I tried to explain it with the third point, more or less.
No, transport is different.
Okay.
Transport is basically the amount,
outside
transferring data through the GSM, Wi-Fi,
AWS, whatever.
What I'm talking about is today, if you look at the utilization of data in the cloud, it is less than 10%. So customer pays for 100% of the data storage, whereas his value out of that 100% is only 10%. The cost of data archiving is one of the critical.
Yeah, to summarize a bit, maybe on what you were saying, is that most of the data that you will send onto the cloud will not be utilized or has less meaningfulness. So by not sending it over, you will have a more efficient solution overall. Yeah, thank you. So what are the main challenges that you will face by building also a general IoT application, not just related to AI? maybe you will have a rough idea on what the main components you will need by creating an IoT application. You may want to read some data from some sensors. You may want to store the data inside the device, and maybe you want to do some processing of this data before sending it to an external location. What you really need to think of later is all the integration work that needs to be done for this. So, for example, if you read data from a sensor, then you need to convert it into a format, into a data structure that can be understood by other components. And this is a critical part of the application. And then you may have different external sources that you want to send the data to, and you may have to do some protocol translations. Maybe not everything is over MQTT. And besides of that, you need to think of also about security. When you deploy large fleets of devices, you may want to manage them remotely. You may want to update the configuration from the cloud console, for example, and performing also over-the-air updates. So you need a reliable way to authenticate messages and to be sure that you're really talking to the main to who you are intended to talk. So in Eurotech, we developed this software that tries to face all these challenges, which we call the Everywhere Software Framework. It is based on an open source project, which is called EclipseCon, which we are also the maintainers and owners. And this software is mainly built for running on Linux machines, and we sell it usually on devices like small gateways and also more powerful edge servers, which can also do more powerful AI calculations. So as I said before, one of the main tasks of an IoT application is to read data from a field protocol. Here I listed a few of those that we support, but there are many others. And in ESF, we have this concept of drivers and assets. So a driver is the actual implementation of the underlying library that actually reads the data from the field, whereas the asset is the logical representation of a resource that you're interested in. It can be a register or whatever else. Once you have collected the data with an AI workflow, you want to make it process so that it can do, so that it can execute a machine learning model based on it. Recently, we have integrated a new set of APIs, which we call the inference engine APIs, that allows you to communicate with the inference engine implementation. Here I've listed the one that we are providing, which is called the Nvidia Triton inference engine. If you don't know how it works, it's really simple. You copy the model in TensorFlow, Keras, or also straight Python onto the device file system. Then you attach a configuration file to it so that you can define a mapping for the inputs to the inputs of the model, and you can map also the output of the model to an external application. With ESF, this mapping is done for you, at least partially. You have just to define a very small set of mappings onto the NVIDIA configuration file, and so that you can fed the inference engine with data, and you can collect some machine learning results. Then you can save the results and persist them to some database of your choice. I've listed a few here. Redis is very popular for image recognition stuff. And you can send then the data onto a cloud service. Here I put the MQTT protocol because it's the first one that we have implemented in our history, but we support also many others. ESF exposes a set of MQTT endpoints that allows you to remotely manage the device in a secure manner. And this is leveraged by the Everywhere Cloud counterpart, cloud counterpart. Everywhere Cloud is the cloud software that allows you to manage the whole fleet of devices. You can send down, provision the devices with certain certificates. You can install external packages onto the device, and you can update the configuration of all the other components that you see here. Then, as a bonus, recently ESF is also a container manager. So if you have an existing IoT application that is running on a container, ESF is now able to connect to a registry, to a Docker registry, download the image and manage its life cycle. Then with ESF you can also manage network interfaces that are on the machine. We had a legacy implementation which was not really portable, and lately we switched to a network manager based one. The network manager implementation is more portable since this tool is available across many Linux distributions. So we made it possible to have just 3 generic installer packages, one for each architecture. So ARM32, ARM64, and x64. And yeah, everything is powered by OSGI, which is a well-known Java framework for building microservices. So everything that you see here is a microservice. In OSGI, we refer it as to bundles. So each of those is a bundle, and each bundle has a configuration attached that you can change at runtime. And so OSGI, what it does is it manages all these dependency injections, configuration updates, and so on. So moving forward, how does the operational side look like? So first, for developing an AI application, we usually need to install these additional components. We have the implementation of the inference server, which is based on Nvidia. And then we have a wire component that we will explain later. Then we configure the Nvidia Triton inference engine with the location of where you want your models to be put into the file system and other security settings. And the Nvidia Triton can be run in 3 modalities. It can be run natively, so you can leverage a GPU if you have one on the device, an Nvidia GPU. It can be remote or containerized. For example, a use case for a remote implementation could be that you have a couple of little gateways that are there just to collect the data, that are connected to a bigger, more server-like gateway that can do actually the inference. Last, in ESF, we have this programming tool that we call Wiregraph that lets you connect everything into a data flow model. It's very visual, it's very quick also, and yeah, every piece that you see there it can be a database, can be the AI part, or a cloud publisher over MQTT. Here specifically, sorry for a bad resolution, it's the AI component that is based on 3 steps: the pre-processing, the main inference operation, and then the post-processing, and that's optional. So now that we have configured the device, our prototype device, with the configuration that we want to deploy across a fleet of devices, we can take what we call a snapshot of the device. So it's a XML or JSON file that contains the configuration for all the components that we have configured into the ESF framework. Then we can move to the Everywhere Cloud console and create a device activity that runs an Ansible playbook onto the device, on the target devices, that copy the models into the correct path on the file system. And yes, and downloads also the model. And finally, we can create a batch job to perform the rollout to a large fleet of devices. In this batch job, you can define the requirements, as we have seen before. So the AI package for the Nvidia Triton implementation and the component for the wire graph. We can upload the snapshot that we've taken before from a prototype device, and then we can roll out the device activity to make the device download and set up the model onto the file system. This framework, this also operation modes are really flexible and allowed us as Eurotech to be in many different industry sectors. So speaking of AI, we have many applications currently running to detect wildfires and floods. Then we have some applications that inspect the roads and the railways for defects. And we have several applications also running in passenger counting. Not speaking of AI, we are active in many different segments too. So now I give the word to my colleague Pierantonio, which will talk more specifically about security.
Okay, thanks Marcello for introducing to ESF. So now we want to focus this talk on security. So we want to know which risk we have if we deploy an application on the edge, on an edge device, and in particular, what will happen if we deploy an AI applications on our AI model to the edge. Machine learning in general, AI applications are a new field, and now we are starting to use this type of application and deploying it on edge devices. But this represents a new attack surface, and according to several research, this is the security concern is one of the top blockers for the adoption of this technology, especially in edge devices. Okay, so the edge AI security is part of a wider picture because not only the application is a risk, has security challenges, but all the flow is a surface attack. Consider, for example, a typical IoT application, a typical IoT flow. We have an edge device, an IoT gateway, that is deployed somewhere in the field. It collects data from a sensor on the fields, then process the data inside, and then send the result on a cloud platform using some communication infrastructure. Your edge device is not in your data center, but is deployed somewhere, I don't know, on a factory or on a train. And so someone can access physically to the device, so it can take control of it using some vulnerabilities, can intercept communication to the cloud platform, or can take control of the device, for example, stealing some sensible data or your AI model. So imagine this scenario. Your company has spent a lot of money and time for developing your AI application. It's collect data, it's process the data, develop the AI model, train the model, validate with a real use case, and then deploy the model and the application on an edge device. And then there is somewhere that can access your device and steal your application, your model. It's not a big deal for your company. So what we can do to prevent this situation? For sure, we need an integrated approach. So we need to secure all the levels of our application, from the hardware to the OS to a framework and application. We need to use secure device and certify this device. For example, this one is a Relygate 1014. He's obtained two security certification, the PSA and the IEC 62443. And this was obtained securing all the levels. In particular, ESF has a central role in this case because it allows the user to properly manage the device and the application in a secure way. For example, ESF can be configured with a policy that prevents the installation of unwanted software. All the bundles that are installed in ESF should be signed with a key on certificate. Remember, the bundle is a small portion of code that represents our application and is deployed on ESF. ESF can manage all the networking and file configuration of the device, so it is possible to, I don't know, disable some network interfaces for reduce the surface attack, or implement some specific firewall configuration to prevent attackers to connect to the device. Other features like flooding protection, tamper detection, file system monitoring, and so on. It should be noted that ESF is based on an open source project, EclipseCon, that is a very solid base to build secure application and deploy on an edge device. But what about our AI model? So we need to protect also the AI model that we have deployed on the edge. So, ESF implements the model protection using encryption. More in details, in our development environment, we have developed our AI model. It's a set of files that can be encrypted with some algorithm. Then the file is deployed on our edge device or a fleet of devices, and ESF at this point will manage the model. Usually, inference engine like Nvidia Triton does not support encrypted model, so it needs to be decrypted, decompressed, and decrypted, and sent to the inference engine. ESF manages all this procedure and remove all the decrypted resources from the device. So at runtime, only the encrypted one is present on the edge device. But yeah, let's see it in action. This is the demo that you can see at our booth 6. Is a prosthetic arm. The core of this demo is a Dynacore 4411 equipped with ESF. ESF is configured to run the AI model that is connected to a camera and a prosthetic arm. The camera takes a picture of your hand. The AI model runs in ESF, detect the position of the fingers, and then we send the position to prosthetic arm that is able to mimic the position and of your arm, of your hand. Every cloud is used for collecting data from the for the position, and also for sending data directly to the prosthetic arm. So this is possible to move remotely the arm that is connected to ESF. The core of the application is made with a wire graph. In the lower branch, we have an AI block that represents our inference engine, the Nvidia Triton server. In this block is loaded the model, and the output are the position of the fingers and the end. the controller used for controlling the prosthetic arm. The upper part, upper branch, is used for connecting to the Everywhere Cloud, so the cloud platform, and also for receive commands from remote. Moving into details, the model is represented with a set of files that should be arranged in a specific folder structure. This folder is compressed, encrypted, for example using OpenPGP, and deployed to the device. It should be noted that this feature is available only for local Triton server deployment. This is because ESF needs to control the lifecycle of the server to send the decrypted models, and only if the inference server is running on the same device of ESF, this is possible. Regarding the configuration, this is the web UI of ESF, and in particular of the Triton server. We need to set the password for the decryption. And yeah, that's it, the configuration, there is nothing to do. And this is the result. This is a very short video. We have the camera that grabs the picture for your hand and the position of the fingers. The data are sent to edge device, and the AI application detect the position and send the data to the arm. You can see it in action at our booth. Okay, so to conclude, Marcello presents ESF, presents how many challenges are when we want to deploy application on the edge. There are a lot of security aspects that should not be ignored, and they are not trivial when we consider the whole picture, so the workflow. And in particular, the AI model is an important asset that you want to protect. ESF and EC are frameworks that can help the users to develop secure application and deploying on the edge. Thanks. Questions?
How do you ensure security in the federated learning concept? Okay, so in the federated learning concept where multiple nodes learn from each other, the security has to be one notch above. For example, I have, similar to you, I have 10 cameras, I have 10 hands. Each of them learns on its own. And then I have a model which actually is a collaborative model learned from all the 10 cameras. In that, security has to be quite different than a single node layer. So how do we address those kind of scenarios?
If this works. So the encryption of the AI model is just a little part on the whole security of the whole framework. So every communication, if you're using ESF on each node, all the communication is done in a secure manner. So every data that you exchange back and forth is encrypted and is protected. So I guess this is the second level security that we also provide with this framework.
Thank you.
Thank you.
Other question? Yeah.
You said your edge deployment platform was OSGI based. Did I get that correctly? And can you add some more words to that?
Yeah, so EclipseCon and ESF are based on the OSGI. Mm-hmm. So As Marcello said, we develop a set of bundles that provide services to the... Yeah? Okay. And yeah, each feature is described as developed as a bundle, and each bundle provides services to other bundles. So it's possible for your application to use multiple services that are provided by the framework. Okay.
Thank you.
Other questions? No? Okay. Thank you very much. See you at booth 6.
The EclipseCon.
Enjoy the Eclipse.